ladies, we are going to jump right into chapter 7. Chapter 7 is all about exponential functions, so they have exponents. And later on, we'll talk about functions that will undo exponential functions, right? Multiplication will undo division. Something has to undo exponents. So when we start off, we're going to start by graphing. And notice it's both growth and decay. Well, if you're growing, that means that you're getting bigger, right? When something is decaying, there's less of it. So when we graph our parent function, which is y equals b to the x, it could be either growth or decay, depending on whether it's getting bigger or smaller. So if you follow that first Desmos link, it is going to take you here. So this is our parent function when b is equal to 2. So we have infinitely many parent functions, all depending on what number has the exponent attached. So when that number is 2, if you have y equals 2 to the x, then you get these 3 points, 0, 1, 1, 2, where 2 is that b value, and negative 1, 0.5. Well, remember that 0.5 is 1 over 2. So for exponential growth, notice this is growth because we're going uphill, those are our 3 parent points. So pause the video here and write out your 3 parent points for your exponential growth. Our domain's going to be all real numbers, and our range is going to be all positive. So y needs to be greater than or equal to 0. That is because of that horizontal asymptote. So that horizontal asymptote means that we will never cross the line y equals 0. It's going to get closer and closer to it, but if we zoom in, there's still a little bit of space there. So we never actually cross y equals 0. Now, when we have exponential decay, that is when b is somewhere between 0 and 1. So if we let b, if we can get it to stop at 0.5 or close to it at least, 0.6 works, then you still have those same 3 points. You still have the point 1, b, whatever that b is. So if we let b be 0.25, we still have the point 0, and we still have the point -1, 1 over b. It involves a little bit of fraction work, but it's still the same 3 parent points. Your b value is just a little different, and that's okay. So our domain and range and horizontal asymptote is what that's called. A horizontal asymptote, we usually abbreviate HA, but your points are the same for growth and decay. It's just a question of whether your graph is going uphill and leveling off as you go to the left, or whether it's going to be going downhill like decay and it starts to level off as you go to the right. So we often draw in that dotted line for our horizontal asymptote just to show that we're never actually going to cross that point. So now we also talk about transformations of exponential graphs, and these are already wrote in because we are pros at this by now, right? If you throw in an A, H, and K, we know for sure what it's going to do every single time. So the one piece that's new about this box is it also talks about what our horizontal asymptote is. That is going to affect where our graph levels off, but good news, it's always going to be related to that K value, right? Because K always shifts you up or down, so that's going to affect where you start to level off. So in example 1, we want to graph, and in our homework, I identify our parent function for all of these. But remember that it's just y equals b to the x. That b is whatever number is being taken to the exponent. So we start, as always, with our parent points, and we shift those. So we have the point 0, 1, -1, 1 over b, which for us, b is 3. So -1, 1/3. And then the point 1, b, where b is that 3. And then this function had an h value of -1, which means we're shifting to the left. That is going to affect our x coordinates. So when we move left 1, that'll leave us at -2, -1, and 0 instead. Those are the 3 points we are going to graph. So we've got -2 up 1/3, -1, 1, and 0, 3. So sure enough, we know that this is exponential growth. And that's one of the questions we are asked to answer, because we can already tell that we are going uphill. Now, as we go to the left, we need to identify that we are going to level off at the line y equals 0, because our horizontal asymptote, HA, is always going to be related to your K value. But we didn't have one. So if we didn't have one, that means it's automatically K. So as we draw more of our graph, we show that it levels off as we go to the left. In example B, this time our parent function is y equals 5 to the x. So we have our parent points related to y equals 5 to the x. We've got 0, 1, 1 comma b, and our b is 5 this time. And then the other point is negative 1, 1 over b, so 1 over 5. Now, this function has two y coordinate transformations, a and k. We have to go, you can either think alphabetically or using PEMDAS. Multiplication first. So we are going to take each y coordinate and multiply by 1/2, because we have a vertical shrink. Well, 1/2 times 1/5, if you want to plug it into your calculator, you'll find that it's 1 over 10. 1/2 of 1 is 1/2. 1/2 of 5, we often will just leave it either as a fraction, 5/2, or if you want to write it as a decimal 2 and call it 2.5, that's okay too. Then after that, we need to shift our function down 2. So we take each of these y coordinates and we are going to subtract 2. So that's going to leave us with negative 1 and 9/10, and then negative 1.5 and positive 0.5. Those are the new y coordinates we need to use. So negative 1, just shy of negative 1.5. So we'll go orange, or excuse me, just shy of negative 2. So left 1 down almost 2. 0, negative 1.5, so barely above that, and 1 comma 0.5, so just like that. Before we connect our points, notice a couple things. It is going to be exponential growth because we are getting bigger, and our horizontal asymptote is going to be related to where our K value shifted us. We moved down 2, so our horizontal asymptote is y equals negative 2. So we will draw that in as a dotted line. It's not actually part of our graph, but we want to show that we are considering it when we make our graph. And in example C, we have a parent graph of y equals 1/6 to the x. So this is when we really start to have fun with fractions, when we consider our 3 parent points. So we still have the point 0, 1, that never changes. And then we have the point 1 comma b. Well, our b is a fraction, it's 1/6. And then the x coordinate of negative 1 gives us 1 over b. Well, here is your trick. If you take 1 over a fraction, you just find the reciprocal of the fraction, aka you flip it. So we have the point negative 1/6. Now, the only transformation this function has is a reflection because a is negative 1. So we take each y coordinate and multiply by negative 1. So we'll have negative 6, negative 1, and negative 1/6. And we plot those points. Negative 1, negative 6, 0, negative 1, 1, negative 1/6. Now, this one, it does look like it's going to be increasing, and it will, but we are leveling off as we go to the right. So, because of that, and because our K value is non-existent, or it's invisible, so it's 0, that tells us our horizontal asymptote of y equals 0 means that we're going to level off as we go to the right. So as we level off to the right, kind of looks something like that, and it looks like that. Because our b value, which remember is the thing with the exponent attached, is less than 1, that tells us that it's going to be exponential decay. Now, we're increasing for our graph, so it looks kind of funny, but that's really only because our graph is reflected. So if it was not reflected, it'd be clear. Oh yeah, we're getting smaller. That would be decay. And our last graph, we have example D. We have a parent graph of y equals 0.6 to the x. So our 3 parent points consist of 0, 1, 1b, which is 0.6, and then negative 1, 1 over b. Well, if you type in 1 divided by 0.6 into your calculator, it gives you 1.6 repeating. Then this one has 2 transformations. Our h causes our graph to shift to the right 3. So then we have positive 2, 3, and 4 for our new x coordinates. And then our k causes our graph to shift up 4. So we take each y coordinate, we add 4. 5.6 repeating, 5, and 4.6. So those are the ordered pairs we will graph. We have 2, 5.6, which will leave us here, 3, 5, and 4, 4.6. So very close together, but we can tell that we are decreasing. Now let's think about our horizontal asymptote. So that is related to our k value, remember. So our horizontal asymptote, this time we have a k of 4. So that means that we level off at y equals 4. So we draw on that dotted line, we connect them, we know that we are going to be decreasing. This is exponential decay because that graph, or excuse me, that parent point, that b, is less than 1. So that is all we need to know as we graph exponential functions. We are going to have another video that talks us through exponential growth and decay application problems.